In this video lesson, we're going to look at the skill of using prime factorization to help find the greatest common factor, which is often abbreviated as the GCF. As Math 10 students, this is important for us because finding the greatest common factor, or GCF, is a common application of prime factorization, and other questions that we'll see in this unit that might be about subdividing a portion of land, or setting up students in lines, or creating an array, or sharing. These are all questions that are greatest common factor, or GCF, in disguise. In order for students to be able to successfully follow along with this lesson, you should know what factors are, you should recognize exponential notation, and be comfortable with the expanded and exponential notation forms of 11 multiplied by 11 multiplied by 11 multiplied by 11, or 11 to the power of 4, and you should be able to quickly and comfortably say that 52 can be rewritten in its prime factors as 2 squared multiplied by 13. The greatest common factor is the largest factor that's shared by all of the numbers that are being compared. It's also called the greatest common divisor. Now, something important to note about our greatest common factor. When you are asked to find a greatest common factor, your answer can never be larger than the smallest number in the list of values you're comparing. It might be equal to the smallest number, but it can never be larger. In previous courses, when you were asked to find the greatest common factor, you might have started by making a list. So perhaps we list all the factors of 24. And then we do the same thing to list all the factors of 60. Once you've created the list of all the factors, we start going through to compare. 60 is not a factor of 24, 30 isn't, 20 isn't, 15 isn't. But 12 is the largest number that shows up on both lists of factors. The problem is that this strategy becomes very, very time-consuming for the kinds of questions that we're going to see in grade 10. So our strategy is going to rely on prime factorizations. Let's take a few moments and find those prime factorizations now. Through the magic of video, here are our prime factorizations. In expanded form, when we look for common pieces, both pieces involve a 3 and at least 2 2's multiplied together. In the exponential notation, both pieces involve a 3 to the power of 1. Both pieces involve powers of 2, and the smallest number of 2's that we have are 2 of them. So then our greatest common factor will involve those 2 multiplied by 2, the smaller of the exponents, and 3 to the power of 1. When we expand this, we find that the greatest common factor is 12. So here's our strategy to find the greatest common factor using prime factors. We start by finding the prime factorizations. Notice which factors are in each, using the smallest exponent for those common factors, and then we multiply or expand those pieces to figure out what our GCF looks like. In this next example, we're going to use prime factorization to find the GCF of 36 and 44. This will be a good time to hit pause and find your prime factorizations. So double check that you agree the prime factorization of 36 is 2 squared multiplied by 3 squared, and our prime factorization of 144 is 2 to the power of 4 multiplied by 3 squared. Notice that each of these involves a 3 squared. That will be part of our greatest common factor. They also each involve a power of 2. In this case, we're going to choose the smaller power of 2. Our greatest common factor will involve 2 squared multiplied by 3 squared. And using our calculators to help us out, this greatest common factor is 36. Since that is equal to, but not larger than one of the numbers in our list, this is a perfectly acceptable answer. In this example, we'll look for the greatest common factor of 216 and 324. Once again, this will be a good time to pause and find those prime factorizations. If you're having difficulty with prime factorizations, finding the greatest common factor is going to be tricky. So if you're noticing as we continue the video that you're not coming up with the correct prime factorizations, that's a good sign to come in for extra help. If you are being successful, let's start with our comparisons. Both factorizations involve a power of 2. We're going to use the smaller power of 2, and our greatest common factor will involve 2 squared. Both factorizations also include a power of 3. Once again, we're going to use the smaller power of 3, in this case 3 cubed. Using our calculators to help us expand, 2 squared multiplied by 3 cubed, the greatest common factor of these two numbers will be 108. In our last example, we're going to find the greatest common factor of a list of 3, and once again, we'll pause now to find the prime factorizations. When we found our prime factorizations and we begin to compare, we notice that there are some prime factors that belong to some numbers, but not all of them. For example, 7 is only a factor of 2,240, so it will not be part of our greatest common factor. And 3 is a factor of the first two numbers, but not the last. 3 won't be part of our greatest common factor either. All of our numbers include a power of 2. The smallest exponent is a 5, so our greatest common factor will involve 2 to the power of 5. And all of our factorizations involve 5 to the power of 1. In expanded form, this greatest common factor, then, is equal to 160. So reviewing our strategy, we find the prime factorizations for each number, look for the factors that are common to each list, choosing the smallest exponent where necessary, and then we use our calculators to help us multiply or expand to find that greatest common factor.